Good morning. A warm welcome to my channel. This is Bhargavi. So in this video, I'm going to explain you a short of data structures. So whatever the SEM syllabus you have in Telangana University third SEM data structures, so that I'm going to explain you in brief. Okay. So the first, what is data structure? So data structure is a collection of data and storing the data in such a manner that you can access the data very efficiently whenever we require. So this data structure is going to be divided into primitive data structures and non-primitive data structures. So primitive data structures in the sense predefined data structures. Non-primitive data structures is nothing but not predefined data structures. Again, in this primitive, you have linear data structures and non-linear data structure. In the linear data structure, again it is divided into four types: array, stack, queue, and linked list. Whereas non-linear data structure is divided into trees and graphs. Okay, so already we know array is nothing but collection of elements of same type of data could be stored in a single variable is called as array. So we'll discuss in the next sessions, that is stack, queue, and linked list. So when you enter into the subject, first the topic is introduction to the data structures, and the next topic goes to the algorithms and pseudocode. Now, algorithm is nothing but a finite set of steps and to perform a specified task. We have different kinds of characteristics for the algorithm, that is input, and it should have an output, it should be finite number of steps, and the algorithm whatever you have specified, that is correct. And the last one is complete, whatever the algorithm you are writing, that is suitable to your task. Next, pseudocode. So we have a small difference between algorithm and pseudocode. Algorithm is nothing but it is developed with the help of the common English language in the form of step 1, step 2, step 3, whereas pseudocode is the combination of human language as well as in the programming language, and is also has set of rules. Example for the algorithm is: consider step 1, take two numbers; step 2, add two numbers; step 3, display two numbers. Whereas come back to the pseudocode, here you have input as well as output. Whatever the input you are giving to that pseudocode, you have to specify in the input condition, output condition. But that means what output you will get, that you have to specify, and any return statements if the task is having, that return statement also you have to specify, and each and every statement must be numbered 1 2 3 so on, like this. So it is a combination of some programming languages and some part of the human language. Next, we enter into the data structure, that is stack. So stack is a linear data structure. In stack, only one end is open. So here this is a stack diagram. 0 1 2 3 are the locations of the data elements. Whenever you insert an element, we call it push. Whenever you are deleting an element, we call it as pop. So in the stack, only one end is opening, right? So from this end only push and pop operations can be done. Initially in the stack, we'll consider the top variable as -1, and we'll consider the size of the stack also. Now, how to check whenever you are pushing and whenever you are popping from the stack elements, we have to check whether the stack is full or not. So if you want to insert an element, you have to check a condition that whether the stack is full or not. So to check the condition, if top is equals to -1, size -1, then we say stack full, you cannot insert the element. If stack is not full, increment the top value by 1 and insert the element into the top position. If the stack is empty, whenever you want to perform pop operation, first you have to check whether the stack contains any elements in the stack or not. If the stack is empty, how to check? If the top is still -1, you cannot delete the element. Why? Because stack is empty. If the stack is not empty, what you have to do? Take out the element and decrement the top value by 1. So this is a stack full condition. This is the stack empty condition. Next, some of the stack applications are reversing a string, expression conversions, processing of function calls, checking well formed parentheses. Next, we'll discuss about the recursion. So, what is a recursion? Recursion is called as a process in which a function calls itself is called as a recursion. So recursive functions are nothing but the function name and calling function name also same. Such function is called as recursive function. Such process is known as recursion. With the help of this recursion also you have many number of advantages and disadvantages also, and we goes to the discussion of types of recursion. First one is linear recursion, binary recursion, tail recursion, mutual recursion and nested recursion. In linear recursion, a function, for example, I am calling a function x. Now in that I'll call the same function x. Now this function is going to call this function. This is called as a linear function. That means one after the other, if you are executing the same function, that we call it as a linear function. Next goes to the binary recursion. In binary recursion, binary means what? 2. That means in the place of whenever you are calling this recursion, if I call our recursion function 2 times, then we call it as a binary recursion. Next, tail recursion. Tail means what? At the last. Now whenever a function is having at the last step before closing of the bracket, if you are calling a function, that means same function, that we call it as a tail recursion. Next one is mutual recursion. For example, a calls b, b calls a. Such function is called as mutual recursion. Here a is calling b, b is calling a. Nested recursion, that is in the sense a calls b, b calls c, c calls a. Next we will discuss the next topic, that is queue. So queue is also a linear data structure like the stack, and queue also having ADT and the stack is also having ADT. ADT stands for abstract data type. So abstract data type are the functions which are predefined in the stack header file as well as the queue header file. Now in this queue the two ends will be opened, whereas in stack one end is open. In queue two ends are open. That means from one end you can insert the data, from other end you can delete the data. Whenever you are inserting, we increment the rear value. Whenever we are decrementing, whenever we are deleting, we increment the front value. Consider this is an empty queue. Initially, my F and R are at the same location. F is at 0, R is at -1. If I insert an element, then R becomes 1 position. This is 0 number, 1 number, 2 number, 3 number. When I insert 20, then R goes to 1. When I insert 30, R goes to 2. When I insert 40, R goes to 3. But still F is at 0 location only. That means you can perform deletions from using front variable. You can insert the variables by using rear variable. Clear? If I delete this F, that means if I delete this 10, I want to increment the value of F from 0 to 1 location. That means whenever you insert, whenever you perform NQ, that means we are incrementing rear value. Whenever you are performing DQ, we are incrementing front value. Clear? Now here initially two things here we did. Front and rear you can consider as -1. Other case is front is 0, rear is -1. So queue full, queue empty conditions we have to discuss. Whenever you want to perform NQ operation, NQ, that means insertion, by using rear, you have to check whether the rear is reaching size -1 or not. If rear is not reaching the size -1, increment the rear value by 1 and insert the element into the rear position. Similarly, if you want to delete an element from queue, first you have to check whether the queue is empty or not. So for emptiness condition, this is one condition, this is another condition. Rear is equals to -1. If you consider front and rear as -1, this is a condition. If consider front is 0, rear is -1, this is a empty condition. Okay, so whenever you are emptying, if the condition is satisfied, you cannot display sorry, you cannot delete any elements. Why? Because queue is already empty. If the condition fails, what you have to do? Delete the particular element and increment the front value by 1. So that is the NQ and DQ operations of the queue. Next, queue applications. So queue means what? Forming a line. So in bus stations we form a queue. In schools also we form a queue. Queue means first come, first out. So the major thing you need to understand here is FIFO principle. FIFO. That means first in, first out is a principle of queue, whereas LIFO is a principle of stack. Last in, first out. Whichever element is last inserted, that will be outed first in stack, whereas in queue, whichever element is first inserted, that will be outed first. So ticket booking, and in operating system also multiple processes comes. So operating system gives a priority to the first process only. Clear? Next, priority queue. So priority queue in the sense, whatever the numbers are coming into the front and rear variables to the queue, and we give the priority to which number is to be processed first. For example, consider I want to execute this 30 first. 30 element I want to execute, so I am giving the priority as 1. Next I want to execute this, I am giving the priority to this. That means based on the given priority, the data must be processed in the operating system. So there the priority queue is implemented. Here you have min priority and max priority. If you follow min priority rule, minimum priority will be given first. If you follow maximum priority rule, maximum priority will be taken first. Next, circular queue. So here you have a drawback with the normal queue data structure. That is, if you are deleting an element at this particular location, F is moving to this. If you delete again this, F is moving to this. Now if you want to insert some more elements, I cannot insert. Why? Because here the elements are empty, locations are there in queue, but where is my R? My R is at last position, so I cannot turn back this R to the first location in normal queue, so that I'll insert the data over the two locations. So this is not possible in normal queue. So to overcome this problem, we introduced the circular queue. So in circular queue, I'm inserting the elements like normal queue only. Deletion is also in the normal queue only. For example, I deleted this element. So where F comes? F comes here. If I deleted this element, F comes here. Now, whenever you are inserting an element, for example, consider my R is here. My R is here, rear is here. Now, F is here. This element is not there. This element is not there. F is here. Now, R is at last location. F is at here. These two elements I can insert by using rear variable by making it as 0 and the pointing R here. So what is happening here? If the elements are deleted by using front variables, you can insert them by using rear variable in the circular queue. That is not possible in the normal queue data structure. Next, here queue full, queue empty conditions are there for the circular queue also. So for the queue full is rear -1, size -1 and F is 0 is the full condition, or F and R are at -1. F and R are -1. That is -1 here. That we call as a full condition, and empty condition is F greater than or F and R are -1. So this is a empty condition. Now the next is double-ended queue. So double-ended queue is nothing but insertions and deletions can be possible from both the ends. So this is NQ, DQ, NQ and DQ. Next, QADT. So NQ, DQ is full, is empty, front and size. All these are the predefined functionalities of queue header file. If you want to define the definition for this, you cannot add queue header file. If you want to use this predefined functionalities, you must include the header file of queue into your program. Next data structure is linked list. So linked list is also a linear data structure. It is a collection of nodes. So the node consists of data and address of the next node. So here in the linked list, first we'll store the data, next we'll store the address of the next node. So this is a head node, data link, data link, data link, and data link. So this node is connected with this node is connected with this node, and last node must be not connected with any node. That node link must be null. So if the next address is there, consider here we have single linked list, double linked list, circular linked list. In single linked list I have 4 nodes, 10, 20, 30, 40 are the data. The address of this node is 101, 102, 103 and 104. So in this you have address of next node. Where the next node? 20. That address is 102. So 20, the next node is 30. The address of this will store here. Next 30, the address of this will store here. Now this is the last node, so it is not going to connect with any other node, so you will specify as null. That means a node contains the last value as the address as null, that we call it as a last node. In the double linked list also same. So 10, 20, 30 you have. In double linked list you can travel in both the directions, whereas in single linked list you can travel in only one direction, whereas in double linked list you can travel in forward and you can also reverse. Consider this is 101, this is 102, this is 103. In double linked list this node is connected with this node, so the address of the next node is 102. This node is connected with this node, so the address of this is 103. Now come in reverse. So this 30, this is here this is a previous node address, this is the next node address, previous node address, next node address, previous address, next node address. So for the first node there is no previous node, we'll write as null. For the second node, for 102, which is a previous node, 101, so you store 101 here. And for 103, next node is not there, so I am writing null. The previous node is 102. So in this way you can travel in both the directions in the double linked list. Next come to the circular linked list. In the circular linked list, the last node is connected back to the first node. Instead of null, you specify here the first node address 102, 103, 104. So the next node is 102, the next node is 103, the next node is 104. Instead of null here, you will write the first node address, that we call it as a circular linked list. Now the operations in any type of list are insertion. In insertion at beginning, insertion at end, insertion at specific position. Next, deletion at beginning, deletion at end, deletion at specific position, and next function is display. So linked list also has ADT, that is create, insert, delete, display and length. All these are the predefined functionalities of the linked list header file. So with this we completed two units. Then we'll enter into the third unit, that is trees. So tree is a non-linear data structure and it can store only hierarchical type of data. So this is a tree. So in this tree, first node is called as root node. All these are the called as child nodes. And A, B and C are the childs of parent A. D and E are the childs of parent B. So this we call it as a edge. These two are belonging to the same parent. So these two are called as siblings. So depth of the tree is nothing but we'll consider from root to specific node. Height of the tree is specific node to leaf node. Next we'll discuss about types of trees. So here we have normal tree, rooted tree, position tree, regular tree, binary tree and weighted tree. Normal tree is nothing but a tree may have and may not have a root node. A tree without any root is called as a normal tree, that may have and may not have. If the root is there for a tree, that we call it as a rooted tree. Position tree is nothing but you have to specify the position of the element in the particular uh, tree, so that we call it as a position tree. That means you have to give the numbers to the nodes, which node is position 1, which node is position 2, which node is position 3, you have to specify. Regular tree. So this regular tree is also called as M array tree, so that all the childs of the node have same number of childs, right? Next, binary tree. So a node a root or a parent node must contain 0 or 1 or 2 child, then the thing is called as binary tree. Then weighted tree, if the node is having a weight, such tree is called as weighted tree. Now we'll have a depth information regarding binary tree. Why? Because it's a very most important topic. In binary tree, every parent node must have either 0 children or 1 children or 2 children only. That means consider this tree. See, 1, 2, 3, 4. Now every parent is having 0 or 1 or 2 child only. Then this tree is called as binary tree. For example, if I am writing like this, so this is not a binary tree. Right? Now we have different types of binary trees: complete binary tree, full binary tree, strictly binary tree, left skewed binary tree, and right skewed binary tree. So strictly binary tree in this sense, 0 or 2 child only. Left skewed binary tree example, like this, only left childs are there. Right skewed binary tree is nothing but only right childs are there. Complete binary tree is nothing but uh, all that all the leaf nodes are at same level. Consider an example over here. See here. Now this is a complete binary tree. All the leaf nodes are at same level. This is level 0, level 1, level 2. So all leaves are at same level. So this is full binary tree, or you can also call it as extension binary tree. For example, in order to make complete binary tree, if a node is not there, what you do? You'll add a dummy node here. So then it becomes what? Complete binary tree or full binary tree. This tree is called as a extension binary tree. Next you have tree traversals: in-order travels, pre-order and post-order. In in-order traversals, first we specify the left, then root, then right. So here the left is B, then A, then C. So this is a in-order traversals. If the again B is having any child, then again we go for the left of the B, then we see B, then we see right of the B. Next, pre-order traverses. In pre-order traverses, first we visit root node, then left node, then right node. So here A is root, left, then right. In post-order traverses, first visit left, then right, then root. So B, C, A. Again, if the childs of A, B and C are is having again subchilds, then we move on to the same process. Next, the third unit, second part, that is searching. So searching and sorting are the different techniques. Searching is means what? First, linear search. Consider you have the elements as 10, 30, 20, 50, 60. In linear search, one after the other, one after the other, one after the other, one after the other, the search element is searched. If the element is found, we stop the process there itself. But in binary search tree, the rule is that first elements must be in a particular order. That means that must be ascending order or descending order. Consider here 10, 30, 20, 50, 60. They are not in order. For binary search tree, first the elements must be in order: 10, 20, 30, 50, 60. Then we break this into two parts, and the search element must be compared with the middle element. If the search element is greater than the element, then we go for left right sublist. If the key element is less than the left element, less than the middle element, we'll go for the left sublist. So this is the technique of binary search. Next we have sorting techniques. We have 5 types of sorting techniques. For this sorting techniques, you can watch my channel. I already posted regarding these 5 topics in my channel. If you want to need explanation of the sorting techniques, go through that. Next, fourth unit, that is hashing and file processing. So hashing is nothing but a key value pair is there. For example, you have a some kind of data, and this data must be stored in this particular positions. So which element is stored in which location is decided by a following technique called hashing. K mod 7. So K is, consider any elements from this. Consider 10 mod 7. The remainder is 3. So 10 is going to be stored at a location 3. Next, 2. 2 mod 7. The remainder is 2. So 2 is going to be stored at 2. Next, 3 mod 7. Again 3. So already 10 is stored at a location 3. So there will be occurred a collision. If any collision is occurred, then we have different types of techniques. Right? Next, first method is separate chaining method. So here the separate is there. separate chaining method. In separate chaining method, so first 10 is stored at 3, next element is added and stored, that is 3, at the same location by adding as a chain. Next we have linear probing, quadratic probing, double hashing. Linear probing is nothing but, consider here the elements are 0, 1, 2, 3 and 4 location is there. Now here 10 is already stored. Now 3 is also having the same location. So for this what we need to do, instead of adding like a chain, in linear probing we go and search downside. Wherever the empty space is there, there will store 3. If the empty space is not there, again we'll go back and search from the first and store it where the empty location you find first, that particular location you are going to store the number 3. That is linear probing. In quadratic probing, double hashing are the different techniques compared to the linear probing. So we have different kinds of formulas for this. Next we also have types of hashing methods like folding method, squaring method, mid square methods, different kinds of hashing methods also we have. And next we come to the part of heap. Heap is nothing but a data structure. So in this heap, like a binary tree only, we'll write the tree in a structure that left and right. But in a binary tree, we have a rule that is root if it is 10, the left side tree must be less than the root and right side tree must be greater than the root. So this is a rule in the binary tree, but this rule is not applicable in the heap. But here max heap, min heap is there. In max heap, all the parents must be greater than their child. Consider an example here, 10. 10 must be greater than their two childs, that may be left side or that may be right side. Will not consider left side and right side, only we consider parents and child relationship in the heap. But whereas in binary tree, left side values are lesser than the binary tree, greater side values are greater than the binary tree root. Root కన్నా ఇటు ఎక్కువ తక్కువ ఉండాలి, ఇటు సైడ్ ఏమో ఎక్కువ ఉండాలి. నెక్స్ట్ మిన్ హీప్. మిన్ హీప్ is nothing but what, parents must be minimum compared to their child. So these are the I have drawn two max heaps only. Min heap is nothing but what, for example 6, parent is minimum, their childs must be greater than that. So parent is minimum, their childs must be greater than the number. So this is a minimum heap. So you have heap sort also. If the tree is given, you have to arrange them values in ascending order, descending order. By using the heap property, you have a heap sort technique. Next, the topic is insertion of a node in heap tree. So whenever you want to insert a node, for example, I want to insert a node here. So if I want to insert a node here, that I am inserting as 7. So whether this tree is satisfying the minimum heap property? No. Why? Because so here 15 is the parent, 7 is the child. So min heap means what? Parent should be minimum, child must be greater. So child is not greater than the parent. So what you have to do, you have to interchange the parents and childs in this to satisfy the minimum heap property. So 7 goes here, 15 comes here. Here parent is 6, childs are 7 and 13. So the heap property is satisfied over here. Next, the topic is deletion of a node in a heap tree. Whenever you want to delete a particular element, for example, I want to delete the root. Okay, deletion of a node or deletion of a root. ఏదైనా ఒక ఎలిమెంట్ ని డిలీట్ చేస్తే, ఫర్ ఎగ్జాంపుల్ ఇఫ్ ఐ వాంట్ టు డిలీట్ ద రూట్, లాస్ట్ ఎలిమెంట్ మస్ట్ బి రీప్లేస్డ్ విత్ ద 10. సో దట్ ఈస్ 3. Okay, now here the element is not there. Now this property, max heap property, is satisfying or not, you have to verify. If the max heap property is satisfied, then the tree is correct. If not satisfied, then you must swap, interchange the parents and childs to satisfy the max heap property. Clear? Next we have file processing techniques. So in that only 2 to 3 questions are important, that is file organization methods and hierarchy of memory. So go for that. If you like this video, please share and subscribe to my channel and share to your friends. Thank you.